Imagine a world where you can navigate effortlessly in complete darkness, not with your eyes, but with sound. A world where every flutter of a moth's wings, every twist of a leaf, and every jagged rock in a pitch-black cave is mapped out in perfect detail, not by sight, but by listening to echoes. This isn't some futuristic technology, it's the reality. Bats live in every single night. These mysterious creatures possess one of nature's most astonishing abilities, echolocation. But how does it really work? The truth is far more fascinating than you might think. Bats are the only mammals capable of true flight, and for many species, their survival depends on their ability to see with sound. Echolocation is essentially a biological sonar system. Bats emit high-pitched calls far beyond human hearing, and then listen for the echoes that bounce back. By analyzing these returning sound waves, they can determine not just the location of objects, but their size, shape, texture, and even movement. Some bats can detect obstacles as thin as a human hair, all while flying at high speeds through dense forests or dark caves. Not all bats use echolocation, though. The larger fruit bats, known as megabats, rely on their sharp eyesight and keen sense of smell to find food. But the smaller, insect-eating microbats depend entirely on echolocation to hunt. Their calls are produced in the larynx, the same structure humans use to speak, but unlike our voices, theirs can reach ultrasonic frequencies, sometimes exceeding 200,000 Hz. To put that in perspective, humans can only hear up to about 20,000 Hz. Some bats emit these calls through their mouths, while others, like the horseshoe bat, project sound through their uniquely shaped noses, which act like tiny megaphones to focus the beam of sound. Once the sound leaves the bat, it travels outward until it hits an object, a moth, a tree branch, or even a falling raindrop, and bounces back. The bat's ears, often large and highly mobile, are finely tuned to pick up even the faintest echoes. But what's truly remarkable is how quickly their brains process this information. A bat can calculate the distance to an object, its speed, and even its texture. The shorter the delay between call and echo, the closer the object is. And if the echo's pitch changes slightly, a phenomenon called the Doppler-effect, the bat can tell whether the object is moving toward or away from it. This precision allows bats to perform incredible feats. Some species can snatch insects out of midair with pinpoint accuracy, adjusting their flight path in milliseconds. Others can distinguish between different types of prey just by the echoes they produce. A moth's delicate wings create a different sound signature than a beetle's hard shell. But the battle between bats and their prey is a never-ending arms race. Some moths have evolved the ability to hear bat calls and perform evasive maneuvers, spiraling wildly to escape. Others emit their own ultrasonic clicks to jam the bat's sonar, like a high-pitched form of electronic warfare. In response, some bats have adapted by changing the frequency of their calls or flying more quietly to avoid detection. Echolocation isn't just for hunting, though. Bats also use it to navigate complex environments with astonishing precision. A bat flying through a dense forest can weave effortlessly between branches, adjusting its calls based on the surroundings. In crowded caves, where thousands of bats may roost together, each individual modifies its call slightly to avoid interference, like tuning into a different radio frequency to hear clearly. Some mother bats can even recognize their own pups in a sea of identical-looking babies by the unique echo signature of their tiny bodies. Scientists believe echolocation evolved early in bats, possibly as a way to exploit the night skies when most predators were inactive. The oldest known bat fossils, dating back over 50 million years, already show signs of specialized ear structures for echolocation. Over time, different species refined their techniques, some using steady frequency calls for long-distance detection, others using rapid frequency modulated sweeps for close-range precision. Today, researchers continue to uncover new secrets about how bats use sound to perceive their world. Some studies suggest they might even see a kind of acoustic color, interpreting different echo textures to build a mental image far richer than we can imagine. Engineers are also studying bat echolocation to improve human technology, from sonar systems to medical imaging and even self-driving cars. So the next time you see a bat darting through the twilight, remember it's not flying blindly. It's navigating a world of sound, painting a mental picture so vivid that darkness is no obstacle. While we rely on flashlights and night vision goggles, bats have been perfecting their natural superpower for millions of years. That's the truth about echolocation, not just a tool for survival, but one of the most sophisticated sensory systems in the animal kingdom.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.